All right, hello and welcome. This is going to be our homework help video for the homework titled Systems by Graphing That Start in Standard Form. A really important skill for this whole homework is converting standard form into slope-intercept form. Well, in order to do that, we should really know what slope-intercept form is. Got to plug this in. That makes it work a little better. All right. Okay, turn it on. All right, take two. Here we go. Slope-intercept form. That is y equals mx plus b. And it's named really appropriately. This m here is the slope. This b right here is the y-intercept. This form is really easy to graph from because it's got a slope and a y-intercept. So if I can convert these into slope-intercept form, it'll just be much easier to graph. We'll try up here with just one of these easier examples like number 4. We'll be doing it a lot down here. The basic technique is take the x term and move it to the other side. Because you'll notice in y equals mx plus b, y is by itself. So now I've got negative y equals, and then on this side I can choose to put that negative 2x in front or behind the 7. I put it in front of the 7, so it looks more like mx plus b. I then divide everything by whatever the coefficient of y is so that it's a y by itself, like in the equation. And in number 4 here, I'd get y equals 2x minus 7. And it's okay to leave fractions. This didn't have any fractions, but some of these other ones will. You just leave them. And it makes it actually easier to graph because the fractions can turn into the rise and the run, which helps us find the next point. All right, so let's try a problem like number 5 right now. These equations are in standard form. That's kind of difficult to graph with. So what I'm going to do is copy them off to the side and convert them into slope-intercept form. So I'm going to do things like subtract x from both sides, making this 2y equals negative x minus 4. It looks a little bit more like slope-intercept form. Then I'm going to divide everything by 2. Now I've got y equals, and let's talk about this right here. I'm going to write it over here, negative x over 2. Well, this is the same as negative 1x over 2. I can just put a 1 up there if I want, and then I can bring the x out in front to make a negative 1/2 x. So this is going to be negative 1/2 x, and then negative 4 divided by 2 is a minus 2. All right, let's graph this before we deal with the other one. It's got a y-intercept at negative 2, so I put a point at negative 2, and a slope of negative 1/2. Remember, this is your rise. This is your run. So I need to rise negative 1, which actually means go down 1, and then run 2, which means go to the right 2. Down 1, right 2. Or I can just totally flip that around and I can get more points on this line. So I've run out of room over here, but there's more of this line over here. So instead of down 1, right 2, I can go up 1, left 2. And you'll notice if I keep that going, I've made 5 lines, or 5 points on a straight line. All right, that's my first equation. Let's deal with that second equation. Start by copying it down with some space. 3x plus y equals 3. Got to get the y by itself, so I move things away from it. I subtract 3x, leaving me with y equals negative 3x plus 3. Now, fractions are actually easier to graph when it comes to slope, so I'm going to turn that negative 3 into a negative 3 over 1, so I can clearly see my rise and my run. Let's put a point at my y-intercept of 3, and from this point, I'm going to go down 3, right 1, down 3, right 1. See, it intersects that first line. We really wanted it to intersect in one of these bold points, and it did. That makes it really easy to state the solution. The solution is just that point of intersection right there, the point that makes both of the lines true at the same time, the point 2 comma negative 3. Or you can be a little more explicit and say x equals 2, y equals negative 3. All right, let's take a look at number 7, which has got something kind of unique going on. It's got this y equals equations. So a y equals equation it's basically slope-intercept form, but it's got a 0 slope. We could put a 0x in there, and it wouldn't change anything. So the y-intercept of -3 with a 0 slope is just a horizontal line intercepting the y-axis at -3. All right, now for the other line, I write it off to the side with some space. 3x minus y equals -3. I move my x term away from the y. Now I've got negative y equals -3x minus 3. And then I divide everything by -1. Y equals 3x, the negative divided by negative cancels, plus 3. Put a point at 3. I can't go up 3 over 1, so I go down 3, right or left 1. Do that one more time, down 3, left 1, and we found our intersection point. Let's just connect up this line to make it look nice. Circle the point of intersection and state that this point is at exactly -2, -3. Or x equals -2, y equals -3. All right, one more problem. I want to do problem number 11 on the backside. So this one, it's not slope-intercept form, but it's not even standard form. It's just a jumbled up mess of a form. We got to take that jumbled up mess and convert it into something that we can work with, which is slope-intercept form. So I'll take the first equation, write it off to the side. -2y equals 14 plus x. I want to make this look like y equals mx plus b. So how am I going to do that? Got to get y by itself. So I'm going to divide everything by -2. Divide by -2, divide by -2, divide by -2. Now we can see y is by itself. But on this side, this became a -7. And this became a -1/2 x. Looking a lot better, looking a lot more like y equals mx plus b. All I have to do is flip these two terms around, make it -1/2 x minus 7 instead of the other way around. And now that is slope-intercept form, which we know how to graph. We put a point to the y-intercept of -7. From that point, we find our next point by going down 1, right 2, down 1, right 2, down 1, right 2. To get more points, we reverse that and go up 1, left 2, up 1, left 2, up 1, left 2, all the way across the graph. Connect it up with a straight line. There we go. Time to deal with the other equation. We've got 0 equals -5x plus 4y minus 28. Got to make this look like y equals mx plus b. And that starts with getting y by itself on the other side. So to move it to the other side, I subtract 4y from both sides. It cancels on this side. I'm left with -4y equals -5x minus 28. Divide everything by -4. Then I'm left with y equals, the negatives cancel out, 5 over 4x. This becomes just a positive 7. Start at my y-intercept of 7. Now I could go up 5 over 4, but I'd be off the graph, so I've got to reverse that and go down 5. 1, 2, 3, 4, 5. Left 4. 1, 2, 3, 4. Next point, down 5. 1, 2, 3, 4, 5 over 4, 1, 2, 3, 4. Found my point of intersection. Let's connect them up. Straight line. And then we'll really emphasize this point right here by circling it and then stating our point of intersection is -8, -3. Or x equals -8, y equals -3. And you can always double check those by plugging them back in, making sure they make both equations balance. That should be the one point on the whole graph that makes both of these equations true at the same time. All right, well, that's that for this.